What we have here is we're going to go ahead and look at part 6 of problem 4, which I sent out in the last video. And part 6 of problem 4 says the iodine is a yellowish solution. And in problem 4, you had 38% glucose inside. Again, I'm only using GLU. 15% sodium ion inside. 3% potassium ion inside. And 5% starch. Now, I need you guys to really consider what's going on here and really watch those videos I sent out to you, because they explain in detail how easy this stuff really is. It seems complicated because there's a lot of stuff going on, but it really isn't that hard when you break it down and simplify it. All right, so all of these can pass through the membrane according to the problem set to the directions. Outside we have 40% glucose outside the membrane and 20% sodium and 1% potassium. But if we think about it, these are all able to pass through the membrane. So this is going to go to high-low, and you can watch the other video I sent you already, and you should know that these are all going to equilibrate, right? Because they can pass through the membrane, they're going to diffuse. And they'll diffuse until they're equal concentrations on both sides. And they'll continue to move back and forth, but the net movement will be 0, right? The one thing that's weird is this starch, because it cannot pass through the membrane. It can't pass through. Now, they tell you some things here. They say, I'm only going to do part 6 because the rest of problem 4 was sent in another short video. I tried to make each video very short. So you have problems 1 and 2 on one video, 3 and 4 on another video, and then now 5, 6, and 7 on this third one. So iodine is a yellow solution. Starch solution is white. So iodine is yellow. Why don't we go ahead and use yellow? Iodine is yellow. It's a yellowish solution. And starch is white. And when you mix the two together, you get kind of a purplish black. So I'll go with something that looks like that. Kind of a purplish black, okay? And that purplish black is when you mix them together, all right? So anytime you add starch, it's actually much darker than that. I should add a little black to it. I can't really mix them very well, but it's a purplish black. So if you take a starch solution turns purplish by the presence of iodine, if you wait a few hours and add iodine to the beaker, you're going to wait a few hours and what's going to happen in a few hours? Some of the potassium is going to go out, right? Some of the sodium is going to go in. Some of the glucose is going to go in. Is anything going to change with the starch? No, because it's not passing through. So in a few hours, we're going to wait a few hours, and what's going to happen is that we're going to add iodine to the beaker. Now let's remember that this is all inside a beaker, right? You can add iodine out here. What color will the beaker be? Will the beaker in the solution be? What color would the beaker solution be? This. What color will this be? Clear. Oh no, I'm sorry, not clear. Excuse me. You're right. Yellowish. Let me use that color. Yellowish. Why is it yellowish? Because is there any starch outside? No starch outside. Does iodine go through the membrane according to our directions? Yes or no? Look at the directions. Yes or no? Is it permeable to iodine? The answer is yes. Iodine is permeable in this particular membrane. So what color do you think, just out of it's not, they don't ask you this, but why don't we go ahead and answer it anyways. What color is the solution, is the inside the cell going to be? Purplish black. Why does it turn purplish black? Because there's starch in there and the iodine can pass through. So inside it'll be purplish black, on the outside it'll be yellow. So basically what you would get is a beaker that has kind of a yellowish tint all around this cell. That's a purplish black cell, right? So that's basically what you get, right? All right. So we're all understanding that shouldn't confuse anyone. Everybody got that so far? So see how easy that was? We knew that water. And you go on to problem 5, but you'll see that when you look at problems 1, 2, and 3, you'll see how easy it is to tell which way water goes and whether the cell swells or shrinks. And let's go ahead and take a look at this beaker. And we have a cell. We have 5% glucose here, and that's GLU. And 25% starch. And 20% glucose out here. And 20% potassium ion. And 10% iodine. Out of curiosity, who remembers what color then would we be talking about the outside being? That's right, yellow, kind of a yellowish tint. All right. So what passes through this membrane? There's glucose. Yep. So these two will equilibrate. There's potassium. Yes, it does. There's iodine. Yes, it does. Which one's the only one that doesn't?
Starch.
That's right, that's starch. There's always going to be a problem here. So starch does not pass. No, it does not pass. So here's, there's a lot of questions here that they're answering, and I'll get to some of the later questions. Let's quickly think for a second. What's going to happen, and pay attention now, this can pass through the membrane. What's going to happen with the glucose? It's going to equilibrate, right? Everybody good with that? It's going to move to equal out. It's going to rush in. This one's going to rush out. It's going to be somewhere in between 20 and 5. Do you agree? All right, I'm going to make a number up. And let's assume that this is going to equilibrate. And it's going to be somewhere between 20 and 5. And let's just give it a number. Let's say this is going to go up. What's exactly in between 20 and 5? Okay, so 17. So this turns out to be 17%. Outside, 17% inside. So you're going to come to some middle number. All right, that's for glucose. Potassium is 20 outside. Can we just say that inside, for argument's sake, I'm saying for argument's sake, the glucose is going to be 17. Can we say that for argument's sake, potassium ion is going to be 10? 10 in, 10 out? I mean, I'm just saying, it's going to come to some equilibrium. Let's give it a number. All right? So they'll both be 10 in, 10 out. Now, do you understand? Think about it. Of course, iodine is going to be 5% in, 5% out. You okay with that? I'm going to say 5 in, 5% in and out. Because it's only going to rush in, though, right? It's only going to rush in. And this one's only going to rush in, and this is going to rush in and rush out. Everybody good with that? Does anyone have a problem with that so far? This is the time when you should say something. Okay, so everybody understands that so far. So if we did a quick, can you imagine for a second, do you understand this concept that these solutes here really don't impact the difference in concentration outside and inside because they're at equilibrium. So they cancel each other out, don't they? Yes. So we can think of these as canceling each other out. And the same with the iodine, because the iodine also equilibrates. So the ones that can pass through, we can, for calculation's sake, we could actually ignore them, can't we? So I'm going to go ahead and do two different ways of looking at this. The first is I'm going to go ahead and look at the ultimate. After some time passes by, we're going to look at what actually we would expect to happen. And the next is I'm going to go ahead and just say, look, why don't we just make a shortcut? All right. So let's do a little bit of the long way, and say, look, if I get 17, if I'm inside the cell, and after, so this is after some time, right? After a couple hours, 17, it's going to be, they're both inside, now I'm going to 17 outside of glucose, right? Is that right? Yeah. And 17% of glucose inside, and after some time, right? And then after some time, for potassium, I'm going to have 10% potassium out inside. Again, this is all argument, for the sake of a quick discussion, we'll say 10 and 10. Starch is going to be 25%. It's not going to move, right? It's not going in and out. Bless you. Iodine is going to be 5% inside and 5% outside. And there's no starch outside. And see, do you see that that's why this is so important? Because there's 0% outside. Everything else is equal, outside and inside. So because there's none of this outside, that makes this the determining factor on whether the outside is hypertonic or hypotonic, or whether the outside is more water relative to the inside or not. Okay? But I'm going to go ahead and finish the calculation. So inside this cell I have 17 plus 10 plus 5. That equals what?
32.
Do you agree? 32? So that's 32% inside, right? We're talking about inside. Plus, don't forget the 25, don't we? We have 25% that's iodine inside, right? Do you agree? Let me redo this. Let me make a chart. Can I make a chart? Is that better? Let's make a chart. It's always better to make a chart, make it neat. So inside, you have 17%, 10%, 5%, and 25%, right? Those are all what? Solutes. Add those up, please, someone. 57% is correct. So 57% solute. What percent water inside? If it's 50% solute, what's the percent water? 43% water. Do you see that? Do you see that? I see people not looking at the board, so I'm saying those people are not. They're not participating with their brains. They might be sitting there quietly, not interrupting, but they're not participating with their brains. So we have here 43% water. Does everybody see that so far? Do you agree? Any questions? Okay. So now we do outside. Let's take a look at outside, and we have 17%, 10%, 5%. Do we have the 25%? No, we do not. See, that's the difference. There's no 25%. So add this. This is what? 32% outside, plus, and then therefore, what's the percent water? 43%. No, it's not 43. Okay, is it? No. 32. Come on. 100 minus 32, people. Yeah. Huh? 68 is correct. So 68%. So it's 68% water outside. 100 minus 32.
I know, I would get that for both of them, but I don't understand.
Well, in the previous one, I wish somebody would have said they didn't understand before, but in the previous one, it's 57% solute, so 100 minus 57 is what?
43.
Okay? Why people shouldn't be packing up. I know it's time to leave. And I'm going to finish the last two, and make sure you watch the posts. Look at it. In this direction, the water's going to move from what? High to low, from outside to in. I'll finish this in the next class. Go on. So now for an easier way of doing it, rather than just going down and breaking it all down into all these different components, which I encourage you to do for your homework, but would be more difficult to do on a test, is to say, look, I got this beaker, and it has this 5% in the cell inside this beaker has this 5% glucose, and it has 25% starch. And of course there's 20% glucose. You know what, I'm not going to read through all this. So what you need to do is you need to realize that if the solute can cross the membrane, when we're talking about osmosis, asking if there's no osmosis. But if you have a solute that can't cross the membrane, that's going to create osmosis to occur. And if really the only question you need to answer is in which direction is water going to move, if the only questions you're going to answer is water going to move, then the only question you need to answer is there a solute that does not cross the membrane? In this case, there is. It's starch, right? And so, in order to answer this question quickly and easily, all you have to do is worry about starch. Just worry about the one that doesn't cross. If you're talking about osmosis, if they ask you how does glucose diffuse, how does sodium diffuse, how does iodine diffuse, and then they ask you what about osmosis, then you answer each one separately. But if they're asking you, does water go in, and in which direction does it go, and is something hypertonic or isotonic or hypotonic, then all you got to do is worry about the one that doesn't cross, right? Does that make sense?
Yes.
All right, so after time, inside and outside, please pay attention, inside and outside, everything else equilibrates, so they cancel each other out, don't they? It's not going to be any difference between all these other solutes. The only one that doesn't is this starch. And that makes a big difference for water. What made this difference between 68% and 43%? Everything else is the same, except for starch. Right? So 25% starch, and outside is 0. So that leaves you what? What's high, what's low? For water.
The outside is high,
For water, that's correct. Low water inside, high water relative to what? Relative to each other. And I'm talking about high and low concentration. So the flow of water will be inside, towards the inside, right? So then we have swelling. And by the way, that also means that outside you have what? Iso, hypo, or hyper? Hypo. Miller, why did you say hypo? It's what's lower? No.
Oh, wait.
The water percentage is higher. That's why these guys are saying hyper.
Okay.
But what is higher? How do we determine something is hypotonic, isotonic? What's the one thing we're looking at?
What's it called?
When
Ions. The ions.
The solute. Well, hypo means the solute concentration is lower. So if the water is higher, the solute is lower. So this is why this is hypo, okay? So this is hypotonic. That's why water rushes in. If somebody tells you put a cell in hypotonic, you should automatically be thinking, I would put it on index cards, however you want to handle it, I would automatically be thinking the cell is going to swell up. If something's put in a hypertonic solution, I would automatically think the cell's going to shrink. Those should be quick answers on a multiple choice exam for you. Okay? All right. So let's move on to the next problem. The next problem is problem 6. Problem 6 says we have this got a lot of people because they start to use variables, and whenever you use variables, people tend to freak out. They're like, what's X, what's Y? And they have 5% Z. So outside the beaker, outside the cell rather, you have a 3% glucose, you have a 2% starch, Now what I like to do is I like to go down the list and say, does this cross, does that cross, does this cross? So why don't we do that and tell me, you look at the directions, does glucose cross?
Yes.
Yes, that crosses. Does X cross?
Yes.
Does Y cross?
No.
No, it doesn't. And does Z cross?
Yes.
Does starch cross?
No.
So the two we got to worry about are starch and Y, right? Because Z is going to cross until you get about 2.5 on each side, right? And X is going to cross until you get about 2.5 on each side. And glucose will get across until you get 1.5 on each side. Just again, for argument's sake, it's not a real number. I'm just saying they're going to equilibrate, right? They're going to be the same concentration on both sides. So they're not going to be part of osmosis. So I can break this down. I can redraw it, and I can just worry about just worry about 5% Y. And I know that the other stuff's there. It's just equal, right?
Yes.
After some time. And I can worry about the other one being, and outside there's nothing, and outside is 2% starch. The rest of this I can consider water, right? So water outside, what's the percent water outside?
98.
98% outside. It's not, right? It's not 98%, because remember, you still have glucose outside, you still have some X, you still have some Z, right? But I'm not going to worry about that.
Oh.
I don't have to worry about it, because what am I asking myself? Not what is the new concentration. If they asked me that, I'd have to do the longer version, right? Like I just did a minute ago. The only question I'm asking is which way is water moving, right? That's the only question I'm asking, because I know starch is not moving and I know Y is not moving. So I'm going to say 80% outside. What is it inside? 95% water inside. So water's higher where?
Outside.
It's outside, so water's going to move in, right?
Yes.
So the next question is a little more tricky for some of you, and that is this hypotonic, hypertonic, or isotonic?
Hyper.
Hypo. Why is it hypo? It's because the solute concentration. Now, the solute concentration.
Lower.
We're comparing outside first. Is lower outside. I'm worried about outside relative to inside. So outside is lower compared to inside. So it's hypo. That's my answer. Is it hypotonic? Yes. Water rushes in? Yes. Done. See how much easier that was than breaking it down to all the different solutes?
Yep.
But if they ask me which way is the solute going to move and what my ultimate concentration is, you have to be a little more detailed, right? Mm-hmm. Okay, let's move on to the next problem. Oh wait, is that all the questions they had?
No, number 4.
It says, if you were told that one of the molecules X, Y, or Z, right, was a polysaccharide glycogen, which would you guess would be glycogen and why? This is actually a question that has to ask you, do you remember what glycogen is? Glycogen, if you remember correctly, which we don't have time to figure that out, is a long polymer of glucose. It's branched, has all kinds of branches, it's big. Do you expect that this thing is glucose is polar, bless you? Glucose is polar, this is a big molecule, giant molecule.
No.
Is it going to pass through the membrane?
No.
No, so which one do you think this is? Y. This equals Y. So glycogen would be Y.
I guess that too.
And they even tell you, hint, the definition of a polysaccharide. What's a polysaccharide? A polymer of sugar. So sugar is polar, it's a long chain. All right. So that's it through there. Now problem 7. If you're confused, see me after class, right? So problem 7 says we have 5% Y and 5% starch. Pretty much what we had in the last one, right? Mm-hmm. And outside you have 13% iodine and 2% starch. What color is it outside? Quickly. No.
Oh,
Purplish black, right? Purplish black. And so iodine, is it going to cross? I'm going to ask the same questions without even looking at the paper. Yes, this crosses. No, this doesn't cross. Y, does Y cross? Y does not cross. Starch does not cross. Okay. Where's the concentration? Iodine doesn't count. I don't have to worry about iodine, do I?
No.
Unless they're asking me if it crosses or not. It'll balance itself out. It'll equilibrate. Now with starch, I have two. Where are the solutes highest? Highest inside. Right? You all agree?
Yeah.
Here it's about 10% inside solute. Here's only 2%. Right?
Yeah.
So therefore, the next question is, where's water the highest?
Inside.
Let me do this just so it looks ugly. I can't handle it. Water is highest outside. So water's going to do what? Water's moving in. So water's going inside, right? So, what did you say?
You misspelled highest.
Oh my God, I left an H off. Oh wow, the end of the world. All right, so there, it's fixed. There it is. All right, so anyways, I'll remember that when I'm grading your essays. So anyways, when we're looking at a water is highest outside, right? Is this hypotonic or isotonic or hypertonic? Hypo. Why is it hypo? No. Stop. You're going to confuse yourself. Stop. It's hypo because the solute concentration is lower outside relative to inside. And that's it. Don't say anything else. Please listen to what I'm saying to you. Concentrate on the idea if the outside solute concentration is low, then it's hypo. If it's high, it's hyper. And please, don't confuse the water concentration with the solute concentration. Don't confuse these two. Otherwise, you're going to make a big mess of things. Here's a bonus problem. They say, at the end of this, what color is the inside of your cell going to be? It's going to be black or purple, right? Because iodine gets through, right? And we know that the outside, the solution is the outside is also black or purple. Please don't put things away. I'm not done. There's a bonus problem.
Can I answer?
Are these problems examples of active or passive transport? Yeah.
I said active.
Right. It's passive. And you don't know the difference yet. We haven't covered that, so I'm not worried. That's why it's a bonus. It's in the chapter. Reading, if you read it, it's passive. Passive means you're not using any extra energy. And we'll talk more about that next week. That's it for these problems. I'm posting it. Everyone who missed things, make sure you're turning in the notes on the chapter. Thank you. Here's some extra build-a-membrane packets if you need it. I'm done.
Sir,